Hey, it's Phil from Euroheat. Today we're out at a site and I thought I'd tell you about the 3 most common mistakes we see with geothermal heating and cooling systems. So today we're at a project where we're actually redoing the whole system. It's about 2 years old. It's never worked for the client. The contractor that put it in unfortunately didn't get it to work. So we've been asked to come in and we've basically taken everything out and we're putting it back in, just like we do with all our other projects with the right pumps and valves and all the other pieces of equipment. Even though a lot of the equipment here was the right, say, brand, good German or European brands of equipment, the way that it was put together was wrong. But that's not actually one of the 3 mistakes. So mistake number 1 is the ground or the water connection is undersized. And so what that means is, let's say we have a closed loop vertical bore system where there's bores with pipes, they get drilled and placed in the ground, and that's where the energy is either discharged or absorbed from. And they can have a capacity of somewhere between, let's say, 6 to 10 kilowatts each, depending on the particular types of probes used, the depth, the ground conductivity. And let's say you've got a 30 kilowatt nominal heat pump. So what that means is really you might be able to get away with 3 vertical bores if they had the capacity to do 10 kilowatts each. But a lot of people just use these rules of thumb and they don't actually know. And so the capacity might actually only be 6 kilowatts per probe. So that means that instead of getting let's say the 30 kilowatt ground connection that we want, we've only got 18 kilowatts. So we're about 12 kilowatts short. So what does that mean? Will the system still work? Well, yeah, look, 95% of the time it'll still work. There might be 5% of the time where if it's working really hard, it can't discharge enough energy, and so it might trip out on a safety switch to protect itself. But 95% of the time it will still actually work, but out of that 95%, there might be 60% of the time where it's actually working inefficiently, and you might as well have put in a standard air conditioning or standard heat pump, whatever. It was probably a waste of money, to be honest. Investing in this great system if one part of the system is undersized, say like the ground connection, because the heat pump has to work hard and it can't work at its maximum COP and efficiency, and therefore the running cost is actually high. So step 1, make sure that the ground connection, or let's say if it's a water connection like a pond loop or an open loop, is sized properly to be able to maintain high efficiency, high COP of the heat pump. And sorry, one thing that I'll add with the ground connection is the reason why people undersize the ground connections is that each bore might cost, say, $15,000. So if they take one bore, leave one bore off, they might, they're going to present obviously a lower price, and the customer might be more willing to take the job on or accept the quote because they've got a lower price. But really, the customer is going to pay for it in the long run. So it's really important to make sure the ground connection size is correct. The second mistake with the geothermal systems is very similar, but instead of on the ground connection side or the water connection side, it's on the distribution side. So the side where the air conditioning or the floor heating and cooling or the pool or spa or cellar or whatever it is being fed from. And what I mean by this is that you can make the heat pump can produce, let's say, 65 degree water, and sure, it can do that, but the efficiency drops quite a lot. Whereas you really want the heat pump to be producing, let's say, 30, 35 degree water. So what we often see is that systems are poorly designed, and so the heat pump has to work really hard to produce this hot water to try and get the result at the end of the line, which might be heating the pool or heating the floor or the air conditioning. but the heat pump is working so hard, the efficiency has dropped. So it's actually costing a lot to produce that energy. And sort of the whole idea of having the geothermal system with the low energy costs in the first place is negated then. So we have to make sure that the distribution side has been designed with good flow rates, appropriate water temperatures. So let's say for heating, might be 30 to 35 degree water for your floor heating, cooling, might be 35 to 40 for your fan coils or your air conditioning, and then it might be 40 to 45 for your pool and spa heating. For your air conditioning, cooling, look, traditionally it's let's say 7 degree water is used for that. We usually start at 10 and we hover around the 10 to 12 degree water temperature mark. And the reason is that we can get a lot higher COP and efficiency from the system, and it works really well because you don't get that feeling of really cold air being blasted in your face in summer from the aircon. The colder the water, obviously the colder the air that's coming out of the air conditioning. So if we can raise that up a little bit, it makes the room much more comfortable. But look, the downside is we have to make the pipes a little bit bigger, we have to make the air conditioning units a little bit bigger. But in the scheme of things, if you're looking for efficiency and comfort, that's the way to go. And so mistake number 3 is the assumption that geothermal heating and cooling is going to cost you nothing to run. So you're going to invest a bigger amount to start off with, but that's fine because it's not going to cost you anything for run, it's going to run for free, right? And if someone says that to you, then it means they don't know what they're talking about. And it sounds harsh saying it, but it's true. So what you really want is to ask people for numbers. What's the payback period going to be for this geothermal system? And you need to look at the assumptions that they put in. Now, every system is different. It depends how it's designed. But I can tell you generally, a geothermal system in, let's say in Perth or in Australia, might be 40% less to run if you compare it with an air source system. So that's great, right? But okay, let's say the air source system costs 100% to run. The geothermal system's only costing 60% to run. So if you start getting energy bills, they're not going to be 0, they're going to be 60% of what you could have expected. So it still costs something to run, but at a discount. So you need to make sure that whoever you select to do the work for you, be it the design or the construction, or in our case the design and construction, actually gives you those options. Because we see a lot of the time that people they love the idea of the geothermal and they put it in, and I've seen systems where it's been a complete waste of money because they should have just put a simple air source heat pump in, and it would have worked, would have given them the exact same running costs. You can get ones that are really quiet, so it would have been almost the same result. And for, let's say, 60% of the cost, 50% of the cost, something like that. And they've just been sort of, I guess, led into this fantasy or this dream that the geothermal is going to solve all of their energy problems, where it's not. So to recap, we've got our 3 issues. The first one is the ground connection is often undersized. So you need to make sure that is sized appropriately, and that is one of a big factor in making sure your heat pump runs efficiently. The second one is that the distribution side is undersized. So, running on high water temperatures, which means the geothermal system has to work really hard to produce those temperatures, and it costs a lot of money to run, which defeats the whole purpose. And the third common problem is assuming that it's going to be free, basically. There's not going to be any running costs. You're not going to have any bills. That's totally not true. You will get heavily discounted bills, but as I said in the example before, it might be 60% of what you would pay at the full cost. But having said that, if you have a heat recovery geothermal system, like we have behind us here, those bills are actually even more significantly reduced, because we're using the energy which would normally be dumped, let's say the heat that would normally be dumped into the ground in summer, we're sending that directly to the pool. So the ground connection, it doesn't even get used in summer. And that means that We have free pool heating, free tap hot water heating, and free spa heating, and so therefore the running cost reduces even more. So you've heard me talk about the 3 common mistakes that we see with geothermal systems, and I think the important thing is to realise that geothermal systems aren't the solution to every problem. So if you would like some honest advice about whether a geothermal system is worth it and whether it's not, and we might push you into the basket of it's not actually the best solution for you, please do find us at euroheat.com.au and send us an email or give us a call, and we'd be happy to help.